In this video, we're going to cover some basic fraction vocabulary. So let's start off with what a fraction is. A fraction is one or more parts of a whole or a set. And a fraction has two parts, which is a denominator and a numerator. So here we see a bunch of representations of fractions, and the idea is that we don't have a whole amount, so we want to represent a fraction of something. And I think this idea of associating the word of with a fraction is extremely helpful. So if we say, we have 1/3, well, 1/3 of what? 1/3 of a pizza, 1/3 of the amount of money I made last year. It should be associated with a whole or some set. All right, so the denominator, this bottom number, is the number of parts a whole is divided into. So again, we have to think about what the whole is, and we're going to divide that whole into a certain number of parts, and the denominator tells us how many parts. The numerator, which is the top number, tells us how many of those parts that we are counting. So we're going to look at some specific examples, and that should help clear things up. So first of all, before we look at splitting something up, let's make sure we understand what a whole number is. So a whole number is any number from the set 0, 1, 2, 3, 4, 5, 6, etc. And I always remember a whole number starts with the number with the whole in it. All right, it starts at 0 and then we start counting up. So in this picture here, the whole is a circle. So this one circle is representing one whole, and we have 12 of them here. So this is an example of 12. All right, so let's look at a fraction. Now, the first type of fraction we're going to look at is called a proper fraction. And a proper fraction is a fraction where the numerator is less than the denominator. Here we have a numerator of 3 and a denominator of 4. Now, when the numerator is less than the denominator, that means we have a value less than 1. Remember, the denominator tells us how many parts the whole is cut into. So here we are cutting the whole into 4 parts. 1, 2, 3, 4, right? And we are counting 3 of those 4 parts. So that is what the numerator is telling us. We're counting 3 of those 4 parts. So this green shaded area all in here represents 3/4 of the whole. And so this is what the fraction 3/4 would look like. Okay, and that's a proper fraction. An improper fraction is when the numerator is greater than the denominator. So here we're still taking a whole and we're still cutting it into 4 pieces. So if you look down here, the circle is the whole, and we're cutting it into 4 pieces. So this whole's cut into 4 pieces, this whole's cut into 4 pieces. And then we have 9/4, so we want 9 of these pieces. So let's look down here. Let's look down here and count these pieces. Do we have 9 pieces? We've got 1/4, 2, 3/4, 4/4, 5, 6, 7, 8, 9. So each of these pieces represents 1/4, and we've got 9 of them. So the total amount is shown here is 9/4. So we would, if we wanted to color this in, all right, that'd be 4/4, that would be 8/4, and this much would represent 9/4. Now we could also look at that and we could say, well, shoot, this thing is actually worth 1 whole, right? We've got 1 whole right there. We've got 1 whole right there, and then we have a 4th right there. And if we add those up, we see that's 2 wholes and 1/4. Now that is what we call a mixed number. So a mixed number is going to have a whole number part and a fraction part. So over here we see that the mixed number 2 and 1/4 is equivalent to the improper fraction 9/4. These are the same amount of pizza or whatever it is that we're counting here. So in this example, these are cut into thirds, right? We have 1 whole here, 1 whole here, and then a 1/3 here. And so we have 2 and 1/3. Now let's say we wanted to convert that to an improper fraction. So we want a numerator bigger than a denominator. Well, what we're going to do is we're going to count the number of thirds. All right, so let's count them. Let's see, is this color going to show up? 1, 2, 3, 4, 5, 6, 7. So 2 and 1/3 is equivalent to 7 thirds. Now some of you may have seen this little shortcut of how to do this, where you take the whole number part multiplied by the denominator, add the numerator. 2 times 3 is 6 plus 1 is 7, and that is your numerator of your improper fraction. The denominator of your improper fraction is the denominator in your mixed number. Now that's a little trick and it works, but I really want you to see why that works and what's happening. So let's take a look at this 2 times 3 business here. When I take 2 times 3 and I get 6, what am I really counting there? Well, I'm counting the number of thirds in this part of it, in the whole number part. This part has 6 thirds. And then I'm adding on the 1. Well, why am I adding on the 1? That's this piece, right? That's this piece right here. I'm adding on the 1/3 that's in the fractional part of the mixed number. And so that gives me a total of 7 thirds. Now, equivalent fractions are fractions that basically represent the same amount or part. So let's say this was some kind of a sheet cake. I don't know why I'm always using food examples, but and we cut it into 3 pieces, and then you ate 2 of those pieces. Okay. Well, what if we have a equivalent or a same size sheet cake, and we cut it into 6 pieces, and you ate 4 pieces? Did you eat more food? No, you ate the same exact amount of food. Yeah, you ate 4 pieces instead of 2, but the pieces were smaller. And we can see from this picture, you would end up eating the same amount. So these are called equivalent fractions. And we saw an example of equivalent fractions on the very first slide. You may have not noticed it, but if you look here, you see that in a particular row, all these fractions would be equivalent to each other. And you can see that they're equivalent because you can reduce any fraction in this row to the base fraction here of 1/3. Let's see that. Let's pick, how about 6/18? So if I pick 6/18 and I divide the top by 3 and I divide the bottom by 3, that reduces down to 2/6, and I could also divide by 2 again, and that reduces down to 1/3. So the 2/6 is in my list as well. So everything in each row, all the fractions in a particular row are equivalent. All those are equivalent. All right, all these are equivalent. So having some basic knowledge of fractional vocabulary is important when you start working with fractions. So I hope that helped.